Hello students. Today we are going to discuss about functions, but before that we will discuss about relation first. It's not same as the relation you might have seen in the society. So this relation over here, uh, when I talk about relation over here, so relation is a set of ordered pairs between two variables, I can say x and y. Say a relation is given to me, say r is equals to 1, 2, and then say 3, 4, and say 5 and 6. This is just one example. Now, this relation is giving us a set of rule between the first value and the second value. Now, all these first values are known as domain of the range. So when I have to write the domain, I'm going to write 1, 3 and 5. Whereas if somebody asks me what is the range of it, what is the range? So range is going to be 2, 4 and 6. So this is going to be range. Okay. So relation is a kind of ordered pair. Why we call ordered pair? Because all the elements, the first element and the second element will be always written in this form. First element will be written over here and the second element will be over here. Now if you want to represent an arrow diagram and we want to show a relation between these two, so what I'll do, I'll just put 1, 3, 5 on this side, 2, 4 and 6 on this side. So now as my 1 is related to 2, so I'll just make an arrow between the two. 3 is related to 4, so I'll just make an arrow. And 5 is related to 6, so I'll just make an arrow like this. So this is called the arrow diagram. There can be another examples for relation also. Say r is equals to, I can just write 1 na, 2 na, and say 3 and c. So when I'm going to ask about, if somebody will ask me about domain, so domain is going to 1, 2 and 3 and range will be A and C. If I'm going to make an arrow diagram for this, so my arrow diagram will be something like this, 1, 2 and 3 and A and C. So I'll just join these two. 1 is, you can just see 1 is related to A, 2 is also related to A and 3 is related to C. So range, in this range, my domain is here and my range is over here. So range is A and C and domain is 1, 2, 3. So that is what is relation. Now when we talk about function, so if I talk about function, function is a kind of relation. Function is a relation only. Function is a relation with some restriction. Some restrictions. Now what are these restrictions that we are going to see just now? So function is also a kind of relation, but there will be some restrictions on domain. So let's see. Now when I talk about function, so first I'm going to give you the typical definition of function. So function is a kind of relation. You can just see function is a relation, and when it's going to be called a function, any relation will be called a function if fx on all elements on domain of x values. And second, over here I should have added and, because both the conditions should fulfill, condition number A as well as B. If both are fulfilling, only then any of the relation will be called function. So first, the condition is that all the elements of x should be associated. That is the first thing. And second thing, that each element of domain with one and only one. This is the most important condition over here. One and only one element of the range. Now what is the meaning of this? Say I have, and that is a notation given that if y is a function of x, then we can write this as y is equal to fx. Say I have two functions over here. One is A, I'm really sorry, two sets. So one is A 1, 3 and say 4, and whereas I'm going to write B and say I'll just write A, B and C. Now what I'll do, I'll just write few relations. First I'll just write few relations, and then we will identify which of these relations are actually functions. So say I'm just drawing a Venn diagram. So this is 1, 3, 4 over here, and then A, B and C over here, and then this is the second one. This is my first, and then the second one I'm going to draw over here, 1, 3, 4, and then A, B and C. This is the second one, and then I will go to the third one, say 1, 3, 4 and A, B, C. This third relation, I'm just going to tell it. These are just, I'm just writing it. Now I'll just give example of it. Till now I'm just writing. So I'll just use arrow diagram and I'm going to join it, and then I'll tell you whether which of these relations will be called function and why, using the two mentioned criteria over here, criteria A and criteria B. So say 1 is related to A, say 3 is related to 4, A and this, okay, and then I'll take the next one. 1 is related to B, so this is the one, and then I'm going to take another one. 1 is related to A, 1 is related to B, and then say 3 is related to C, and then 4 is related to C. Say 4 is related to C over here, and then say 1 is A, 3 B. Okay, now and say I'll join it to A. 4 is related to A. Now if I see this one and I refer to the two conditions given over here, that all the elements should have some image over here. So let's check out. 1 has an image over here. Same way 3 has an image as A. 4 also has an image. So all the elements of this domain has, or they have, some image over here. So this is A and this is B. 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 So all the values of domain of set A or set A have some image. So condition first is fulfilled. Now second condition is no element of A can have two images. You can just see A, 1 is related to A, 3 is also related to A, 4 is related to A, but no element of this is associated to two of the images. So that means this type of relation will be called a function. That is the first thing. So this first one is function. This is function. Let's talk about 2. Now in the set A has 3 elements, 1 and 3. 1 has an image, 3 has an image, but there is no image for 4. And so that means our first criteria is not fulfilling. So this is not a function. Now if I take the second one, see 1 has a pre-image, 1 has an image, 3 also has an image, 4 also has an image, but you can just see over here 1 is there, and this one has two images. One is associated to A, one is associated to B as well. So that means this is also not my function. This cannot be function because the second condition is not fulfilled. And the second condition said that each element of domain can be associated to one and only one element of the range. Now if I talk about this, say first we are going to check the first condition, condition A, that all the elements of domain should have some image. So 1 has an image, 3 has an image, 4 has an image. So first condition is fulfilled. And 1 has only one image, that is A, 3 has only one image, that is B, and 4 has one image, that is A. So both the conditions are fulfilled. So I am going to call that this is also a function. Now all these values A, B, C are called images. So if I'll write this in as a function, if I'm going to write it, I will write 1 is related to A, and then I'm going to write let me erase it first. Now I'm going to write the second one. So if you can just see over here, 3 is related to B, so I'll just write 3B, and then you can see 4 is related to A. So over here, image of 1 is A, image of 3 is B, and image of 4 is again A over here. So A is called image of 1, whereas 1 is called pre-image of A. So this is called image, and this is called pre-image of A. Pre-image. Now, you might have wondered that why we are not talking about any of the restrictions on B. Why all the restrictions are on A? All the restrictions over here are on domain. There is no restriction on codomain over here. So when we are going to study types of functions, at that time we will see types of functions or classification of functions. In that we are going to take restrictions on B, and that is how the functions will be classified. So this is what is a function, and this is how we identify whether a relation is a function or not.